Hi, I wanted to talk a little bit more about box 1.2 in your text. Oops, I have to make it. There you go. This is the box on quantitative aspects. So ecology is a highly mathematical science. We are not going to delve too deeply into the statistics, but I do want you to understand what a p-value is and what statistical significance is. Statistics are a tool that ecologists use to determine if there is a difference between the treatment group and the control group that cannot be explained by chance alone, given a certain degree of error. There is a high degree of variation between individual organisms, even of the same species. When we talk about evolution, you'll see that that is, in fact, desirable. It makes telling the difference between our treatment groups and our control groups more challenging. If you read a scientific paper that is experimentally based, you'll likely encounter something called a p-value. The P stands for probability. A p-value is the probability that there is a difference between treatment and control groups that isn't explained by chance alone. It takes into account the variation that is natural between individuals in a group, even of the same species. Because we are trying to disprove alternative hypotheses, the lower the number, the more likely there is a difference between the treatment and control. If that's confusing, you're probably paying attention because it really is confusing. We will not be calculating p-values or dealing much with them, but I do want you to know what they are. I do want to clarify something. Many people confuse the p-value with the strength of the association. In other words, the size of the difference between the groups, and that is not true. A p-value does not tell you anything about the amount of difference in groups. A p-value just tells you that the difference you are observing between the groups, treatment and control, are likely true. In other words, it tells you if there is indeed a difference between the two groups, or it tells you that you're just seeing the effects of random chance. If your p-value indicates that there is a difference between the two groups that is more than just due to random chance, we say that the results are statistically significant. Statistically significant means that the results are likely true, but it says nothing about the size of difference between the two groups. For example, I may do a study on the average number of hours a CCSF student studies compared to the number of hours that a Skyline College student works. I find that City College students study on average 26 hours a week, and the Skyline students study on average 25 hours a week. So City College students study on average 1 extra hour a week. Now I do a statistical test on my data and find that the difference is statistically significant. It means that the difference is likely true. City College students really do study more than Skyline students. But that doesn't mean that it's an important difference. Rather, 1 hour isn't very much. So the term statistically significant doesn't say anything about the size of the different groups. It only says that the difference is likely true. If I compared students at College of Marin, for example, with City College students, I might find the difference much larger. Say that College of Marin students on average study just 10 hours per week compared with City College students who study 26 hours per week on average. But let's say there is wild variation in the study habits of College of Marin students, with some students studying a lot and some not at all. They average to 10 though. The results may not be statistically significant, but they are large differences. I want you to be wary of this, especially when you read medical studies.